The Universe in Motion, an introduction to gravity. Our universe is always moving. Planets orbit stars, stars cluster into galaxies. These celestial bodies are in constant motion, creating a dynamic and ever-changing cosmos. Galaxies spin through the vastness of space, each one a massive collection of stars, planets, and other cosmic material. What is the invisible force that orchestrates this cosmic ballet? The answer is gravity, a force that governs the motion of everything in the universe. Gravity is a fundamental force of nature, essential to the structure and behavior of the cosmos. It is responsible for the attraction between objects with mass, no matter how large or small. From the smallest grain of sand to the largest star, everything in the universe experiences gravity. This force is universal and omnipresent. Imagine throwing a ball into the air. What happens? The ball rises, but it doesn't keep going up forever. It goes up, slows down, and then falls back to Earth. This is a simple yet powerful demonstration of gravity. This is gravity at work, pulling the ball back towards the center of our planet, ensuring that what goes up must come down. In this essay, we will journey into the fascinating world of gravity, exploring its many facets and implications. We will explore its mysteries, from its discovery by pioneers like Newton and Einstein to its profound effects on the cosmos, including the bending of space-time. Get ready to be amazed by the force that shapes our universe, influencing everything from the smallest particles to the largest galaxies. Gravity is often described as an invisible force, a fundamental interaction that governs the motion of objects in the universe. We cannot see it, but we can certainly feel its effects in our everyday lives, from the simple act of walking to the complex orbits of planets. It is what keeps us grounded on Earth, preventing us from floating away into space, and it is the reason why astronauts experience weightlessness in orbit. Gravity is a force of attraction, a natural phenomenon by which all things with mass or energy are brought toward one another. It pulls objects towards each other, influencing the motion of planets, stars, galaxies, and even light. The strength of this pull depends on two things: mass and distance, as described by Newton's law of universal gravitation. Mass is the amount of matter an object contains, and it directly affects the gravitational force it can exert. The more massive an object, the stronger its gravitational pull, which is why planets and stars have such significant gravitational fields. This is why the Sun, with its massive size, holds the planets in our solar system in orbit, maintaining the delicate balance of our cosmic neighborhood. Distance also plays a crucial role in gravity's influence, as the gravitational force decreases with the square of the distance between objects. The farther apart two objects are, the weaker the gravitational attraction between them, a principle known as the inverse square law. This explains why we feel Earth's gravity much more strongly than the Moon's gravity, even though the Moon is quite large. The distance between us and the Moon significantly reduces its gravitational pull on us. Unraveling the mystery Newton's apple and the law of gravitation. The story of gravity's discovery is often linked to a falling apple and a brilliant scientist named Isaac Newton. While the apple story might be an exaggeration, Newton's contribution to our understanding of gravity is undeniable. In the 17th century, Newton proposed his law of universal gravitation. This law states that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between their centers. Newton's law was groundbreaking. It provided a mathematical framework to explain why objects fall to the ground, why the Moon orbits the Earth, and why planets revolve around the Sun. It was a giant leap forward in our understanding of the universe. Gravity's grip on us, life on Earth. Our planet, a blue and green marble floating in the vastness of space, is held together by an invisible force. Gravity is not just a cosmic force, it is an integral part of our everyday lives. It keeps us grounded, quite literally, and influences every aspect of our daily routines. It shapes our planet, governs our movements, and influences our biology. From the majestic mountain ranges to the deep valleys, gravity sculpts the very landscape we live on. The Earth's gravitational pull is what gives us our sense of weight. Every time we step on a scale, we are measuring the force of gravity acting on our bodies. It is why a feather falls at a different rate than a hammer in a vacuum. This difference is due to air resistance, which gravity interacts with in our everyday environment. In the absence of air resistance, both objects would fall at the same rate, accelerated by Earth's gravity. This fundamental principle was famously demonstrated by Galileo. Gravity is also responsible for the tides. The rhythmic rise and fall of ocean waves are a direct result of gravitational forces. The Moon's gravitational pull on Earth's oceans causes them to bulge outwards on the sides facing and opposite the Moon, creating high tides. This celestial dance between Earth and Moon is a beautiful example of gravity's reach. From the simple act of walking to the flow of rivers, gravity plays a constant role in shaping our world and our experiences. It is a silent, ever-present force that we often take for granted, yet it is fundamental to life on Earth. Section 5. Beyond our planet, gravity's cosmic dance. Gravity's influence extends far beyond Earth. It is the architect of the cosmos, sculpting galaxies, igniting stars, and dictating the paths of celestial objects. Planets are held in orbit around stars by the star's gravitational pull. The star's gravity acts like an invisible tether, keeping the planets from flying off into space. Gravity is also responsible for the formation of stars and planets. Clouds of gas and dust in space are drawn together by their own gravity. As they collapse, they heat up and eventually ignite into stars. The leftover material can clump together to form planets. Section 6. Fun with gravity. Interesting facts. Gravity is not all serious business. It can also be a source of wonder and amusement. Here are some fun facts about this fascinating force. Did you know that you would weigh less on the Moon than on Earth? This is because the Moon has less mass than Earth, so its gravitational pull is weaker. On Jupiter, a planet with much stronger gravity than Earth, you would weigh more than twice as much. Black holes are objects with such strong gravity that nothing, not even light, can escape their pull. Astronauts in space experience weightlessness not because there is no gravity, but because they are in a constant state of free fall around Earth. Section 7. The importance of gravity from tides to technology. Understanding gravity is not just an academic exercise, it has practical implications for our daily lives and for our technological advancements. For example, our knowledge of gravity is essential for space exploration. We need to calculate the gravitational forces involved in launching rockets, navigating spacecraft, and landing probes on other planets. Gravity also plays a crucial role in keeping satellites in orbit, which we rely on for communication, navigation, and Earth observation. Furthermore, understanding gravity helps us study the universe and unravel its mysteries. It allows us to map the distribution of mass in space, detect distant planets, and probe the nature of black holes. Section 8. Black holes, gravity's ultimate triumph. Black holes are among the most extreme and mysterious objects in the universe. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. Black holes form when massive stars collapse at the end of their lives. The star's core collapses under its own gravity, creating an object of immense density and gravitational pull. The boundary around a black hole, beyond which nothing can escape, is called the event horizon. Once something crosses the event horizon, it is forever trapped within the black hole's grasp. Section 9. Gravitational waves, ripples in spacetime. In 2015, scientists made a groundbreaking discovery. They detected gravitational waves. These waves are ripples in the fabric of spacetime caused by the acceleration of massive objects. Einstein predicted the existence of gravitational waves in his theory of general relativity. These waves are incredibly faint and difficult to detect, but their discovery opened up a new window into the universe. Gravitational waves provide us with a new way to study some of the most violent and energetic events in the cosmos, such as the collision of black holes and the explosion of supernovae. Section 10. The future of gravity research. Unanswered questions. While we have learned a great deal about gravity, many mysteries remain. Scientists are still working to fully understand how gravity works at the quantum level, the realm of the very small. One of the biggest challenges in modern physics is to unify gravity with the other fundamental forces of nature: electromagnetism, the weak nuclear force, and the strong nuclear force. A theory of everything that could explain all four forces remains elusive. Another area of active research is the study of dark matter and dark energy. These mysterious substances make up the vast majority of the universe's mass and energy, and their gravitational effects are evident, but their nature remains unknown. Section 11. Conclusion. Gravity's enduring influence. From the falling of an apple to the dance of galaxies, gravity is the invisible force that shapes our universe. It is a fundamental force of nature that governs the motion of objects, large and small, from the smallest particles to the largest cosmic structures. Our understanding of gravity has come a long way since Newton's apple and Einstein's equations. We have learned that gravity is not just a force, but a curvature of space-time, and we have detected gravitational waves, confirming one of Einstein's most profound predictions. As we continue to explore the cosmos and unravel its mysteries, gravity will undoubtedly continue to play a central role in our quest to understand the universe and our place within it.